Elon Musk's Neuralink puts computer chips in animal brains. Goal is to cure conditions like Alzheimer's, dementia and spinal cord injuries, fuse humankind with Gertrude pig. Neuralink. Gertrude, the pig with a Neuralink implant in the part of its brain that controls the snout, required some coaxing by Musk to appear on camera, but eventually began eating off of a stool and sniffing straw, triggering spikes on a graph tracking the animal's neural activity. Billionaire entrepreneur Elon Musk's neuroscience startup Neuralink on Friday unveiled a pig named Gertrude that has had a coin-sized computer chip in its brain for 2 months, showing off an early step toward the goal of curing human diseases with the same type of implant. Co-founded by Tesla Incorporated and SpaceX CEO Musk in 2016, San Francisco Bay Area-based Neuralink aims to implant wireless brain-computer interfaces that include thousands of electrodes in the most complex human organ to help cure neurological conditions like Alzheimer's, dementia and spinal cord injuries, and ultimately fuse humankind with artificial intelligence. An implantable device can actually solve these problems, Musk said on a webcast Friday, mentioning ailments such as memory loss, hearing loss, depression and insomnia. Musk did not provide a timeline for those treatments, appearing to retreat from earlier statements that human trials would begin by the end of this year. Neuralink's first clinical trials with a small number of human patients would be aimed at treating paralysis or paraplegia, the company's head surgeon Dr. Matthew McDougall said. Neuroscientists unaffiliated with the company said the presentation indicated that Neuralink had made great strides but cautioned that longer studies were needed. Musk presented what he described as the Three Little Pigs demo. Gertrude, the pig with a Neuralink implant in the part of its brain that controls the snout, required some coaxing by Musk to appear on camera, but eventually began eating off of a stool and sniffing straw, triggering spikes on a graph tracking the animal's neural activity. Musk said the company had 3 pigs with 2 implants each, and also revealed a pig that previously had an implant. They were healthy, happy and indistinguishable from a normal pig, Musk said. Musk said the company predicted a pig's limb movement during a treadmill run at high accuracy using implant data. Musk described Neuralink's chip, which is roughly 23 mm, 0.9 inch, in diameter, as a Fitbit in your skull with tiny wires. I could have a Neuralink right now and you wouldn't know, Musk said. Maybe I do. One comment from a webcast viewer described the animals as Cypork. Pig's limb movement. Musk said the company predicted a pig's limb movement during a treadmill run at high accuracy using implant data. Graham Moffat, a University of Toronto neuroscience research fellow, said Neuralink's advancements were order of magnitude leaps beyond current science thanks to the novel chip's size, portability, power management and wireless capabilities. Stanford University neuroscientist Sergey Stavitsky said the company had made substantial and impressive progress since an initial demonstration of an earlier chip in July 2019. Going from that to the fully implanted system in several pigs they showed is impressive and, I think, really highlights the strengths of having a large multidisciplinary team focused on this problem, Stavitsky said. Some researchers said longer studies would be required to determine the longevity of the device. Neuralink's chip could also improve the understanding of neurological diseases by reading brain waves, one of the company's scientists said during the presentation. Recruiting, not fundraising. Musk said the focus of Friday's event was recruiting, not fundraising. Musk has a history of bringing together diverse experts to drastically accelerate the development of innovations previously limited to academic labs, including rocket, hyperloop and electrical vehicle technologies through companies such as Tesla and SpaceX. Musk, who frequently warns about the risks of artificial intelligence, said the implant's most important achievement beyond the medical applications would be some kind of eye symbiosis where you have an eye extension of yourself. Small devices that electronically stimulate nerves and brain areas to treat hearing loss and Parkinson's disease have been implanted in humans for decades. Brain implant trials have also been conducted with a small number of people who have lost control of bodily functions due to spinal cord injuries or neurological conditions like strokes.